We are going to start now about carbonyl compounds. That's our new lesson, the fifth homologous series, carbonyl compounds. If somebody asks you the meaning of carbonyl compounds, what you have to say is this. Carbonyl compounds contain carbon, double bond, oxygen functional group. This is carbonyl functional group. These carbonyl compounds contain this functional group, divide into two categories, aldehydes and ketones. Those are the two categories, aldehydes and ketones. What are aldehydes? Aldehydes have carbon double bond oxygen carbonyl functional group. Ketones also, they contain carbon double bond oxygen. They both have carbonyl functional group. Now, when I go to ketones, in ketones, there are two R groups attached to the carbonyl functional group on either side. What's the meaning of R? R can be CH3. It can be CH3, CH2. And it can be CH3, CH. It can be something like this also. Anything. They are called alkyl groups. So if carbonyl functional group has two alkyl groups on either side, they are ketones. Aldehydes are compounds like this. Maybe on both the sides of this carbonyl functional group, there are hydrogen atoms. At least there should be one hydrogen atom. It should be R group. So a carbonyl compound changes to an aldehyde if there are two hydrogen atoms attached to the carbonyl functional group, or at least one hydrogen should be there. If there are no hydrogen, they are not aldehydes. So do you see the difference between ketones and aldehydes? Ketones have the carbonyl functional group with two carbon-containing groups on either side, alkyl groups. Aldehydes have two hydrogen atoms attached to carbonyl functional group, or one hydrogen atom at least attached to the carbonyl functional group. This is the beginning to understand the meaning of carbonyl compounds. Now we go to the TUT. In the TUT, we can see carbonyl compounds have the carbonyl functional group. I just explained to you. This is a carbonyl functional group. They are non-hydrocarbons, yeah, definitely, because it has an oxygen. It's a non-hydrocarbon. There are two types of carbonyl compounds, ketones and aldehydes. They both have the general formula CnH2nO. Okay. I'm just inserting alcohol general formula also. Alcohol general formula has one oxygen. Carbonyl compounds have one oxygen. And carbon and hydrogen ratio is N to N. But in alcohols that we finished in the last class, CnH2n plus 2. The difference between carbonyl compounds and alcohols is that there are two hydrogen more in alcohols than in aldehydes and ketones. Now, how many bonds are there around this middle carbon? How many bond groups are there? This is around the carbon atom in the functional area. There are 3 electron groups. This is 1 electron group. This is 1 electron group. This is 1 electron group. Those are the only bonds. If there are 3 bonds available around a carbon atom, it is going to be a planar triangular structure because it has only 3 bonds. So this is planar triangle. If it is planar triangle, this bond angle should be 120. At an angle, this is how we look at the carbonyl molecule. This is a carbonyl molecule, this is a carbonyl molecule. Bond angle is 120, and around the central functional group carbon atom, it has a planar triangle shape. Draw the structures of the following carbonyl compounds and give their names. Actually, draw the structure of the following carbonyl compounds and give their names. This part is wrong, already the name has been given. So in this phase, we can draw the structure of these carbonyl compounds. I'll give you some minutes to complete this work. All what I want is to see the structure. I'll give one example. Here, this methanol, HCHO, this blue highlighted CHO is this carbon, double bond, oxygen, hydrogen. This is how we draw the structure of it. This is how we write that COH. Here we have CHO. And then this unshaded hydrogen comes in this manner. Likewise, if I go to ethanol here, CHO again, C double bond, oxygen, hydrogen. It has CH3 group attached to it. Likewise, draw the 1, 2, 3, 4, 5. And then afterwards, draw the structure of the following compounds. There are 4. Yes. Do this work now, please. Draw the structures. First one, name is given, but we have to draw only the structure. In the second one, only the name is given. So we have to think about how many carbon atoms are there and how the molecules are going to be drawn. I'll take 2-3 minutes and do the work yourself now. I think we can try this out now. We don't have to give so much of time to this. Propanol. Propanol means 3 carbon atom. Al means aldehyde. So I drew 1, 2, 3. CHO is aldehyde part. Always aldehyde part comes in the corner of the molecule. And here we have CH3, CH2. Now D, butanol. But means 4 carbon. It's a 4 carbon containing aldehyde. 1, 2, 3, 4. Butanol means there should be a carbon double bond oxygen and hydrogen. And here we have to have CH3, CH2, CH2. This is the butanol structure. And then pentanol. They are all aldehydes. 1, 2, 3, 4, 5. Double bond oxygen, hydrogen. This is CH3, CH2, CH2, CH2. Now this is propanediol. Prop means 3 carbon. So let me draw 3 carbon atoms first. Propanediol means there are 2 aldehyde groups, one on the right hand side, one on the left hand side. And in the middle we have CH2. This is propanediol. G. 2-methyl propan aldehyde. Prop means 3 carbon. 1, 2, 3. Propanal means carbon double bond oxygen and hydrogen. 2-methyl means from the aldehyde functional group side, second carbon. 1, 2, 3. On the 2-methyl means on the second carbon there's a CH3 group. And this is a CH3. There's a hydrogen atom. This is structure for 2-methyl propanal. Draw the structures of the following compounds. Propanone. Propanone. Propanone means 3 carbon atoms. 1, 2, 3. If it is going to be a ketone, definitely in the middle we have to have a carbon double bond oxygen group. And in the corners we have CH3, CH3. 3-methyl butanone. 1, 2, 3, 4. Butanone, I can write the ketone group somewhere here. And 3-methyl means from the side carbon number 1, carbon number 2, carbon number 3, 3-methyl. And this are all hydrogen, CH3 here. In this corner, CH3. Here we have to have a hydrogen atom. No hydrogen atom here. And then 2-chloro pentan 3-on. Pentan means 1, 2, 3, 4, 5. Because it's 3-on. 3-on means I'll count from here. 1, 2, 3, 4, 5. 3-on means on the third carbon there's a double bond oxygen. 2-chloro means on the second carbon there's a chlorine atom. 2-chloropentan 3-on. This is CH3. One hydrogen comes here. This is CH2. This is CH3. This is a structure for 3-chloropentan 3-on. Next one, pentan 2-on. 1, 2, 3, 4. Pentan means 5 carbon atom. 2-on means if I number 1 here, 2 here, 3 here, 4 here, 5 here. 2-on means on the second carbon there's double bond and oxygen. And all the others are going to be hydrogen now. CH3, this is CH2, this is CH2, this is CH3. Likewise, we can think about aldehyde structures and ketone structures in this manner. You can copy down if you have not done it accurately, correctly. This sentence shows that aldehydes and ketones with the same carbon number are functional isomers. So we are supposed to do the structure for propanal and propanol. We'll do it. Propanal means 1, 2, 3 carbon atoms. Propanal means in a corner carbon we have the aldehyde functional group. This is CH3, CH2. Propanol means again 3 carbon atoms. Because it's a ketone, in the middle we have carbon double bond oxygen. On one side CH3, on this side also CH3. This is how we can discuss about the structures of aldehydes and ketones in the initial stage of this lesson.